My name is Jim Drew, and I'm with Linear Technologies Boston Design Center. I would like to talk to you today about energy harvesting and the 3588-1. Energy harvesting is one of the new areas of power electronics where we are extracting energy from the environment and using it to control remote sensing elements in wireless applications. New developments in the microcontroller with its increased functionality, increased I/O, both analog and digital, and its ability to be able to shut off unused inputs and outputs, resulting in very low power drains. The designers now need to look at how they define their requirements for their energy sources. Now, these sensors would be measuring stresses in beams, temperatures of critical components. It could also be measuring air quality or various other parameters. This information would be sent to the MCU and stored in the MCU's memory. At some later date, it would be then transmitted to some host processor where the data would be processed. The power for this sensor in the past has been either line power or battery power. With this new developments in the ultra-low power microcontrollers, we now have the ability to look at other sources, and that is sources from the environment where we would extract energy from the environment and use that to power these remote sensors. The missing link is the energy harvesting system itself that takes this energy and converts it into usable power. An energy source could be from solar, it could be a heat differential, it could be from a vibration, or it could be RF energy. Solar energy has been around for many years, and we've been using that to power our handheld electronics. In direct sunlight, we can get 100 milliwatts per square centimeter, and in indirect sunlight, we can get approximately 10 milliwatts per square centimeter. A SABIC device is a device that takes a temperature gradient and converts it into electrical energy. Now, this temperature gradient could be from our skin, it could be from a smokestack, it could be from any place I have a differential in temperature. The SABIC device is capable of supporting 10 milliwatts per square centimeter. A vibration could be used with a piezoelectric device that converts either a deflection or a compression of the piezoelectric device into electrical charge. With a piezoelectrical device, we can get 100 microwatts per square centimeter. And the lowest power version is the RF energy, where we would collect RF energy through an antenna, and we can get approximately 100 picowatts per square centimeter. Now, what we need to look at is what does an energy harvesting system look like? An energy harvesting system needs to have your energy source and a transducer to convert that energy to electrical charge. We need to be able to store that charge in some storage element and then convert that electrical charge into a useful voltage that we can use for our sensing circuits. In some applications, we need to have a rectifier circuit. The rectifier circuit will either convert AC to DC, or it will be used to prevent backfeeding of the stored energy back to the source. Now, the LT3588 is a complete energy harvesting solution for high impedance sources such as piezoelectric elements. Within the LT3588, we have the rectifier circuit, we have a low current undervoltage detection circuit, we have the DC to DC regulator, which converts the energy stored from the input storage device and transfers that charge to an output storage device. And we have all the electronics within this to finish a complete electrical harvesting system. Inside the LTC3588, we have an ultra-low drop bridge rectifier. The forward voltage drop is 400 millivolts, and it can support up to 50 milliamps. The output of that would go into our input storage device. We also have a voltage clamp, which clamps the voltage on the input storage element to 19.2 volts, and it extracts any excess energy above that to protect the device. The shunt current for the clamp circuit can sink 25 milliamps from the input bridge rectifier. We also have 2 digital bits that are used to set your output voltage to 1.8, 2.5, 3.3, or 3.6 volts. There's a low current undervoltage detector, which is used to control the buck regulator. We have 2 input bias circuits to control the top side PFET and the low side NFET. Now, the operation is as the input voltage on the storage element rises and it goes above the undervoltage lockout rising threshold, which is 1.2 volts above the output setting, it turns on the buck regulator. The buck regulator then turns on the topside FET, and it ramps the current up to 250 milliamps through the output inductor. At that point, it turns off the topside FET. The bottom side, the N channel FET, turns on, ramps the current down to 0. In doing this, it transfers the charge from the input source to the output storage element. When the input storage device, the voltage across that gets down to 200 millivolts above the output voltage setting, the buck regulator turns off and goes into a low current, less than 10 nanoamp output current load, and then it waits for the voltage to charge back up. Voltage charges back up above the undervoltage lockout rising, it turns the buck regulator on again, and as the output voltage approaches the regulation point, the buck regulator will drive the output slightly above the regulation point, at which point it would enter sleep mode. When it enters sleep mode, it presents less than 90 nanoamps of output load to the output. The output then starts to decay due to load current or leakage currents. When the output drops slightly below the regulation point, the buck regulator turns back on again and recharges up the output storage element. Now, we also have a power good detector. At this point, we have a complete energy harvesting system using the 3588. Now, this is an example of the demo board that's available at your Linear Technology local sales office, or you can go to www.linear.com and request a demo board for the 3588. It consists of the 3588, an input storage element, an output storage element, and 3 other components to complete your energy harvesting system. For more information on the LTC3588-1 and energy harvesting, visit us at www.linear.com. Thank you.